Hi guys. I'll give it a couple minutes and see if a few more people join on. Can you guys hear me okay? Just to make sure. You can type in the chat if you can. Can you hear me?
Yeah, you sound right.
Perfect. Thank you. Okay, let's. Sorry, I just like to give it a couple more minutes. It just turned 6, so maybe I'll give at 6:03. I'll start giving my typical spiel. Okay, I guess I'll just get started and then people join on after. We'll go from there. So I guess first a little bit about me. So my name's Summer. You can totally just call me Summer. I am an environmental engineer. So electricity is kind of something I wasn't totally familiar with, but I've taught a lot of courses here now. So it's something that I've grown to love. Especially I think I've grown to love it too because it's such a good thing to major in. Like I have so much debt. I have 110,000 in debt from my undergrad and graduate school. So I love when people go to community colleges. I love, especially when they do like trade schools and like these valuable careers. So kudos to all of you guys. So also a little bit more about me. So like I said, I have both my undergraduate and graduate degree from MSU in environmental engineering. I currently work full time, which is why this course is so late. This is how I pay off some of my loans. So I work as an EHS coordinator at an automotive facility up in Alma. So I do a lot with electricity there, but more or less it's from like a safety perspective. So it's really been nice to teach this course because I've learned a lot along the way as well. So I think having fundamental knowledge in electricity is important for everyone. So I think it's a great course. So kind of a little bit about how this course runs. If you went to yesterday's meeting, I don't know how much Kim talks about anything. I do know she's done this quite a long time as well. So she is great. But basically how this course is going to run is you're going to have an electricity portion, which is the main objective, I guess, of the course. And then the mathematics portion is, I guess, supplementary. And what I mean by that is a lot of like electrical equations you're going to use and problems you're going to use require math. And so that's why there is this extra math component, because obviously like having that knowledge in math you're going to need in order to solve some of the problems. So that's kind of why it's ran like this. So obviously if you ever need help with any of the math side of it too, I do not mind like re-explaining that, because like I mentioned, being an engineer, like math is my strong suit. So I would be more than happy to help it any way I can. How this particular hour is going to work from here on out. So every Thursday we're going to meet, and basically I like to first end the class and start the class with if you guys have any questions. So I think being online, like obviously like it can be stressful. I did it myself, so I know that, especially having like a professor who isn't as communicative, or I know that's frustrating. So I will try my best to respond to emails at least within the day. If I don't respond, send me another one. I will not care at all. Send me 3 if I'm not responding and it's important. I do not care at all. So I try to be as responsive as I can. And then basically, if you have any questions about how the course runs, if you have content questions for that week, you can ask those. It'll kind of serve as office hours. If no one has questions, I will normally run through a PowerPoint of information that's valuable for your quiz. So if you haven't noticed, I'll actually pull up the syllabus, kind of skim through it. I know you've probably already all seen it. I don't know if Kim talked about the syllabus at all, but I think it's worth talking about, and then I'll talk about the amateur modules and all of that, just to make sure everything's clear. I'll ask for questions. And then if you don't have any content related questions, you can head out. And then if you do have content related questions, you can ask those. And then I'll also go through the PowerPoint that I created for week 1 if you haven't taken the quiz already. So that's kind of a bit how this is going to work. Also, like I said, another thing, like in my old classes, if I had a student who just had one quick question about like a grade or something, and if people just popped on at the beginning, asked a question, and then didn't have any other questions, and then left the Zoom call, that's totally fine too. So you're not required to be here. I love when you guys are here. It makes the hour, because I have to be here an hour anyways. So I love to answer questions and talk as much as I can about electricity. So but all in all, whatever I can do to help and make this course be easy to learn for you and be worth your time, I will try to do everything I can. So with that, is there any questions? If not, I'll kind of talk about JetNet and show you everything from the electrical side. But any questions?
I have a question.
Yeah, of course.
I have like on Thursdays, I have a ELT 150 class
Okay, yeah.
that runs like from 6 to 7. And they're both not mandatory Zoom classes to go to. I'm just wondering like how I should go about doing both classes.
Yeah, so this is what I would recommend. What is ELT 150? I don't know off the top of my head.
Residential wiring.
Residential wiring. Okay, so obviously I think that's going to be a more advanced class. I think this is going to be more of a beginner class. A lot of what we talk about is like, what is electricity, like basic components of electricity. So I think if you understand the main points in this course, I would basically, whatever course you're having the most challenges in is the one that I would go live to, I guess. So if you're having the most challenges in this one, I would stay here, ask the questions, and then if it's the other class, go to that one. I think the other class will probably be the more difficult one for you. So I totally understand if you go to that one instead. In addition, I will always record these, so you can always watch these at any time. I'll post them probably a day later. Sometimes it takes a while for it to load into JetNet, so you can watch. Also, like and this is good to mention to all you, I totally get if you work full-time, if you have other classes, if you need additional help and this hour is not working for you, I will be more than happy to schedule office hours with you individually. So I will be as accommodating as I can there. So if you are struggling and want to talk one-on-one, like for something that's confusing, or you need more clarification on something, we can schedule, just email me and we can schedule something. So I would just play it by ear. Whenever you're having troubles here, join on. If you can't, you can email me and I can help you in any way that I can.
Okay, thanks, Miss.
Yeah, of course.
I actually have 3 questions.
Of course.
The first one, is there a specific day that each weekly quiz needs to be done by, or is it kind of just as long as it's done by the end of the semester?
Right.
Or end of the course?
So I don't have deadlines, and I hate it because there are some students who will seriously wait until the last day, and that is stressful. So I would recommend definitely doing it week by week. So especially because like I've had a lot of, especially the amateur modules, because I know people have had issues with that, like opening it, and they'll wait until halfway through the semester, and then like they're cramming, trying to figure out how to work the amateur modules, how to you know, because sometimes when you click on the link, it doesn't automatically load, and that can be
Right.
stressful. So I would definitely make sure that like the first week you could complete the quiz okay, you can do the amateur modules okay. And then kind of if you're a couple days late on one, it's totally fine. I probably will send emails to you if you haven't done anything in the last couple of weeks, just to make sure you're still enrolled. That is the other important piece that I will email everyone at the end of the week, but just so you guys know. So in order for me to take attendance, you have to, I can see everyone's participation on JetNet. So I can see like how long it's been since they've logged on, and that is what I use to record attendance. Or if you go to this meeting. So if you're everyone on this meeting right now, automatically I know, okay, you're participating this week, you get attendance for that week. So every week I have to submit attendance. So so just make sure that every week you're either contacting me via email, coming to these meetings, or at the very least logging on to JetNet.
Okay.
So that's the only piece of like, if you're gonna, you know, not do the quizzes at a week to week thing, just make sure that you're, you know, doing something for this course once a week, so I have something to go off of.
Okay, and then so for the grading wise, it's just the quizzes within the actual quiz portion and then the amateur quizzes. That's not all the reading, right? And all the supplementary.
Yeah, so
Documents.
that's what I was gonna do next. I will pull, was that your last question?
Yeah. Oh, one other thing, sorry.
No, you're totally fine.
Because I know you get multiple attempts on like the quizzes, but if you get 100% in the first attempt, do you have to go in and do it again or?
No, nope. It'll
Okay, I
take
just
the
wanted to
highest-
make sure.
Definitely only take one attempt. So let me pull up that. Okay. Also, this course, I have both two sections. There's 150 and 151. So sometimes you might see 151 and 150. It doesn't really matter. It's the same course, but I just teach it at the same time. So some of you might be in different sections. So the main things here are this. So your math quizzes is 65 points, your electrical quizzes is 156, and amateur is 70 points. So that's kind of how it's graded. So obviously it's weighted the most by those electrical quizzes, which that's what I spend the most time in these our meetings talking about. So the amateur modules, that is definitely more independent, I guess, unless someone, just because it's hard for me to teach on that because a lot of it is like simulation. So I can't really, it's hard to like teach on it unless you have specific questions. Whereas electrical quizzes is a lot of like math concepts or like definitions, you know, like that type of stuff, conceptual based stuff. So that's why I normally focus this hour on that portion. So, but yeah, that's kind of how it's going to run. I
In
think
the amateur module, sorry, because I know there's the quizzes within that, but that's all we're getting graded for within that
yeah.
module, right? Not the like, listen to every single slide and.
Okay, sorry. Yep, I totally didn't answer your question the first time. Then yeah, the amateur modules, when you open it up, if this is, just make sure I understand correctly, when you open it up, you're gonna see like a pre-quiz, and then it goes through all those like a ton of like reading like straight from a book, and then it has you take a quiz. So that quiz is the only thing that's graded.
Okay.
But I think in order to take that quiz, you have to do the pre-quiz first, which is why I think a lot of people like who save the amateur stuff until like a couple weeks into the course panic because they're like, why can't I take the quiz? It is because you have to click through everything. So
Gotcha.
before you can take the quiz. And I know, like, I think I don't like set up the content for this course, but there's a lot of information every week. I totally recognize that. I think for one, after like if you come to these meetings after I speak, if there's like a area that you're still concerned or confused about, I would watch one of the videos. So if you see it every week, they're all like titles. So for week 1, you have one on AC DC conductors and insulators, you have one for basic circuits, one for electrical diagrams. Kind of, you can watch whatever videos you want to watch. You're not going to be graded for watching them, you're not going to be graded for not watching them. The only thing you're graded on are those 3 things. So any other questions for anyone? No? Okay. So that's pretty much it for this. The rest of it I know is all pretty straightforward. Just a quick overview of how this course is gonna run. So 7 weeks long. It definitely gets more challenging, probably about week 5, 6. That's when it gets challenging. First couple weeks are easy. So definitely make sure you understand the next 3 weeks, because those are crucial to understanding the further later on weeks. So definitely ask questions if you need it. I'm here to help in any way that I can. And then obviously you don't need a textbook for this course either. So everything hopefully is pretty straightforward there. Let's, now I'm just gonna open JetNet. Ooh, okay. Trying to figure out what is on your screen. Can you see my JetNet right now? Is that what's on your screen to you guys?
Yeah.
Yeah,
Okay, perfect. Okay, so this is how it should look from your end. So let's just go to week 1. So as you can see, you have week 1 stuff. The to-do list just tells you everything you should do, but again, you're not gonna be penalized if you're late a day or if you're late a week even on taking a quiz. But you have all your lectures on all of the different content. These lectures right here are what this electrical quiz is gonna be based off of. And from prior courses, I will tell you that these videos are very, very well constructed. There should not be a question that you shouldn't be able to answer after watching all of these. And so definitely, like, if you are, not doing well and very concerned about your grade, making sure that you watch all of these, ask questions when you have them, is really important. Also, I think another benefit of having 2 attempts is sometimes I still tell students, take your first attempt, and then Thursday when we meet, if there's a couple questions that you need clarification on, I can try to highlight those points. So that should also help you too. That's how I think the best way to do this course is to take your first attempt, see what you don't know, see what you're struggling on, and then come here and ask the questions. So, and then, like I said too, like, if you don't want to do any of the quizzes until we meet on Thursdays, that's fine too. So whatever is easiest for you. I think that's the way online classes should work, because, you all have different schedules. So whatever is most convenient for you to do. So when you open up your electrical quiz, you can see I submitted one, which I actually got one wrong. So that's not good. But so basically it'll open it up every week, and then you should be able to hit reattempt quiz here for your second attempt. The Amatrol modules, you shouldn't have to create an account or anything. Those are the pink gift boxes. It should open up this. You hit enter, and then it'll load for a minute, and then it's gonna look like this. So you're gonna have to do, a lot of people just try to click straight to the quiz because that's what is graded, but it will not let you open the quiz. So you have to launch the content before you can open the quiz. So that's why you have to do the pre-quiz, hit launch, do the quiz, and then it'll show up on my end that it's graded. So pretty straightforward there. There's no, I don't think at least, but I don't think there's any final or anything. Nope, doesn't look like it. But like I said, these last few weeks get difficult. So especially like this last 7 week limit switches and everything. But so that's how this is going to work. If there are no more questions, I will probably skim through some of the more important information from week 1, highlight a few of the points.
yeah, I had a question.
Yeah, of course.
So for the, I emailed you about this. I don't know if I haven't checked it yet, but for the Amatrol
Mhm.
basic, so I clicked on it and then I went to go take the test. And like I tried it and I didn't understand. I thought I had to make an account. So I exited out of it and accounted for one of my attempts.
Oh, it did. Oh,
Yeah.
Okay, I'll figure that out.
Okay.
That actually,
Sorry, go ahead.
no, I was just gonna say that is actually a good point that I will send an email about, because it needs to be specified. You only get 1 attempt on the Amatrol quiz. You get multiple attempts on these electrical quizzes. So you get 2 attempts on the electrical quizzes, only 1 attempt on the paint. But obviously in situations like yours where like it exits out, we'll figure that out. So no worries about that. I'll email you tonight and figure out something. So
Okay, thank you.
yeah, of course. I will send an email to everyone about that though, because I think that a few people might have questions about that, like if they can redo the quizzes, which I wish you could, but I don't think there's a way for me to set it up for you to be able to. So sometimes I do also And this I kind of do by on a class to class basis. I get everyone's feel for it. Sometimes I make the Amatrol quizzes pass or fail, and anything above 70 is a pass. So basically, if you get 70 or higher, you get 100% for that module. Anything below 70%, you get a 0 for that module. The reason I do that is because I think it's easy to miss a couple questions, but I don't think it's easy to fail if you're actually doing it. So, and I think like, especially for a course like this, like a 94 is an A. And I know for some of you, getting an A or getting the grade you want is important. And I don't want you getting 9 out of 10, 8 out of 10 on an Amatrol module, not get the grade you want because of something small like that. So I'll probably do that unless you have any concerns about me doing it like that. But I think a 70 is pretty achievable for those modules. Any other questions on this or anything? No? Okay, great. So like I mentioned, I'll just actually I've got to open it. So I'm going to stop sharing for a minute and then open up these slides. So are most of you in the lineman program? I think that's normally what I teach. A lot of people are in the lineman program, but I don't know if that's the same for you guys or no. All right, so share this. And I probably won't take up the whole time, but like this week is pretty short, so we'll go through this and call it good. So at the beginning of the first lecture you'll watch talks about electricity. Basically, I'm going to just talk about the main points that are important for the quiz. Take your attempt. If there's still questions, email me, watch some videos, and I think you will be golden. Electricity is just any form of energy resulting from the existence of charged particles. So that is typically electrons. And it's either statistically as an accumulation of charge or dynamically as current. That all seems like a lot of chemistry. The main idea here is it's just a movement of electrons. So that's what we refer to when we're talking about electricity. Hence, electrons, electricities both have the same, base word there. And this is just a diagram of an atom showing that your electrons are those charged particles that float around your atom. But this is the main idea, just the movement or the flow of electrons. So in basic electricity, we talk about a circuit and the main components of a circuit. So basically a circuit is just a closed path that consists of certain circuit components that electrons can flow through. So here on the right, here's a pretty good diagram. In this situation here, you always have to have a battery or some sort of load in your circuit, and your electrons are moving along this wire. So typically you're going to have like a wire, like a copper wire. If you've ever done like those models, and I think I used to do them in high school, like where you'd have to connect all the wires and then you'd have like loads. So and then as soon as you touched your wire to the battery, you see that light bulb flicker. So that's kind of what this is. That's kind of what that representation is. It's just a basic circuit. One of the most important things on this diagram is this right here. So this switch. So this example is an open circuit, and that is because this right here, this line is open, or this switch is open. So when the electrons that are represented by these arrows get to this point right here where that switch opens up, they're going to stop. So if there's a load, like a light bulb right here, it's not going to light because those electrons are going to stop there. So circuits always have to be closed for electrons to flow completely from the negative terminal here all the way to the positive terminal on the battery. So that's the most important piece of a circuit, and it is a test question. So you must have your circuit closed for your electrons to flow. And it's kind of confusing because like sometimes I think close off, but in this situation, close is on, because anytime it's open, you're having open gaps, so your electrons can't flow anywhere. So I wrote here close equals flows because I think it makes it easy to remember. So, and also another thing here, so your battery is just the source of energy, which provides that push, which is a voltage of energy to get the current flowing in. So 2 words in here, voltage and current, we're going to talk about in a little bit, but that's the main idea there. So You just need a source of energy at the start, because energy, electrical energy, is how you ultimately create electricity. So, and that's what we will talk about that later on, the difference between electricity and electrical energy, because they are not interchangeable. So, like I mentioned, we talked about voltage and current. The other important term is resistance. So those are the three terms that are key for this week. So voltage is the first term, and in some of your quiz questions and the math questions in particular, they're going to denote it V. So in the right corner, you can see I have 80 V or 80 volts. So they're both the same things. If you see 80 V, you can automatically assume that we're talking about voltage there. So voltage is just the push or the pressure that moves those electrons. So obviously, looking back at the switch, your electrons flowing through the circuit, they're not just going to flow. You need something to push it and make it keep going. And that's what voltage is. So it's how much potential energy exists to move your electrons from one specific point to another. But just remembering that it's the push or pressure that's moving electrons is enough. Current is another term that's sometimes it's kind of difficult to, or it's easy to mix up between voltage. So current is the actual speed that your electrons go through the wire. So like velocity is meters per second. Current is measured in coulombs per second, or amps. So amperes, or AMPS, stands for amperes, I think, per second, which is just, a speed. So any type of speed is a distance over time. So coulombs is actually a distance, and seconds is a time. So that's kind of the thing about current. Just remember that it's either represented in amps or coulombs per second. And 1 amps is 1 coulombs per second. So if you you don't have to worry about doing math like converting an amp to a coulomb per second, because they're the same thing. So main thing here is just the speed your electrons are going. And so, a question might say like, how many amps are you going, or how many coulombs per second are you going? So that right there tells you you're looking for current. So it's a quantity of electricity carried in 1 second by a current of 1 amp. So that's what a coulomb per second is. So the third term here, this looks like a long slide, but it's not too complicated, I promise. So resistance is first measured in ohms. So definitely remember that. That is probably something that could be in your quiz too. So, and resistance is basically just the measure of the opposition to current flow in an electrical circuit. And I think there's a lot of complications that can come in when talking about resistance. We're going to talk about later on resistors and the importance of those from a safety aspect in electricity. But for now, I think just knowing that it's just measuring the measure of the opposition to current flow is enough. I mean, we'll talk too about how short circuits, if you have your current going too quickly, it can create hazards and issues. So resistance plays a large portion in that. So there's a lot of different factors that are going to kind of affect your resistance. So some of those include the length of your conductor, which I don't think I have anything on conductors and insulators in here, but if you have any questions, either watch the video or you can ask them or email me or whatever. But basically the length of the conductor, the material of the conductor, the diameter, so how large that conductor is, and the load, all are going to impact your resistance. So the only thing that really doesn't is the strength of the power supply. So that is something that's on your quiz, and I always kind of bring it up because I think it's important, and I also think having a visual is important. So when talking about the length, it's just how long it is there. Area, as you can see here, cross-sectional area normally they're showing that it is like a circle. So that's where I'm talking about the diameter of the gauge right there. So your material also is obviously a big factor, whether or not it's copper or iron in this example, or a lot of different other types of metals it might be, all play a role in your resistance. And then temperature is a big one too. So obviously if it's hot or cold, it's going to play a big factor in that. So you could increase or decrease the resistance in a load by using a variable resistor. So basically the resistive load, this is just kind of explains your resistive load is what you might have in a circuit that's giving you resistance. So it just obstructs the flow of electrical energy in the circuit and converts it into thermal energy. So something that's important about electricity is anytime that we're dealing with energy or electricity, we're dealing with the conversion or the transfer of energy. So for example, batteries don't just have electrical energy in them, they have chemical energy, and we convert that chemical energy into electrical energy. So that's how a resistive load works. It is basically taking the electrical energy that's, making it have a lot of power and a lot of electrical capabilities and turning it into thermal energy or heat. So it's not as, like powerful or strong, which is really important if you have like something that obviously we can't have too much electrical energy going into something like your TV or your appliances. That would not be good. So that's just an example of resistive load and showing you that energy is never created or destroyed. So it's always anything that we put in a circuit, if it's lessening that electrical energy, it's not taking it away, it's just converting it into another form. So that's kind of like if you see something too hot, anything you feel that's hot always came from a different version of energy, because heat is just thermal energy. So like if you rub your hands together, this is kinetic energy, because movement, and it gets hot, that's converting that movement energy, the kinetic energy, into heat energy. So, and that's not important for this week. I just think it's important for later on, especially in later courses. Main things that you should remember for this week is just the main thing here, what resistance is and what factors affect it. So knowing this beginning portion here should be enough. And I didn't talk about this, but I did talk about how it can have issues if you don't have the proper resistance. So the higher your resistance is, the lower the current flows. So if it's abnormally high, it could damage your conductors and due to burning or corrosion, which definitely isn't important. So now that we talked about all three of those, we're going to talk about Ohm's law. So Ohm's law basically is a relationship between voltage, current, and resistance. So there's a few main takeaways here, and this formula is super, super important. So definitely make sure you understand this formula, exactly how it works, because it will come up again. So what the formula is that voltage equals your current times your resistance. And they always have current written as I here. I have no idea why, but it definitely can get confusing. So that's really the only thing in terms of the equation you should remember. Current is always represented as I. There's no rhyme or reason why, but just remember that it is. So the thing that I think is most important about this formula is the relationship between the three of them. So look at voltage and current and voltage and resistance right now. So let's put if you put arbitrary numbers in this right now, like I is 4, or let's do easy. I is 1, R is 2. So you have a current of 1A and a resistance of 2 ohms. Obviously, your voltage is just going to be I times R, which is 1 times 2, which is just 2. But the second we either increase I or R, our voltage is going to increase. So there is a direct relationship between your voltage and current and voltage and resistance. So an increase in I and R is going to give an increase in V. And if you look here, what this is telling you, and we'll do examples of this in a minute, but what this is telling you is that this equation here can be expressed in different ways depending on what you're trying to find. So this is the same equation. This is still Ohm's law. All that we're doing here is find, like for the second equation where it has I equals VR, we're just solving for current. And the way that I found this equation was just doing right here, dividing by, or I wonder if I can annotate. I can. So the way that I found this equation was, you probably talk about this in your math class, but just dividing by R on this side. So my R's go away. Whatever you do to one side, you have to do to the other. So V over R equals I. And that's this equation, just, the I is on this side, but same thing. And same thing here to find resistance. You can just divide by I on both sides, and it's just V over I. So let's do a few examples. I think that hopefully will help clarify if you have any confusions with this, and then definitely ask questions if this is so confusing. I'll be more than happy to do more examples. But so actually, I think there is an example on the next slide. Let's see. I don't have to annotate this. How do I stop my annotation? I guess annotate. Okay. There we go. So I did include this graph, but I can send this to everyone too. This is just showing that we're going to talk about power a little bit later on. As you can see, that's when square roots come into play. But if you ever want this graph, it's sometimes easy to look at. So whatever's in the middle here is what you're trying to solve. So it asks, if the question asks for what is the current, and you're given voltage and resistance, to use this equation here. let's say you're looking for resistance and you're given voltage and current, you know to look here. So it just kind of shows the same equations we talked about here. But okay, let's do some examples and hopefully that will clear up any questions. If not, we will head on out of here. So this is the exact question format that you might get on the quiz this week. So what is the current in a circuit with 15 volts and 3 ohms of resistance? Right away, you should note a few things. If you see volts, you automatically know that you have voltage. If you see ohms, you should right away know that you have resistance. So, and we already know that we're finding current because it asks for it. So we can look here or look back here. We know that we're solving for current. So we use this equation right here, I equals V over R. So it's as straightforward as just going like this. 15V, oh, it's written there, look at that. That is the worst 15 ever, over 3 ohms. And that represents your voltage over your resistance. And it's giving you 5 amps, which again, this number right here, we know is our I, which is just our current. So that is how you would solve a question using Ohm's law. If you want, let's do one more question, but we'll find something else other than current. And then if you guys want me to do another example, I can. If everything's clear and everyone understands everything, then I will open it up for questions. And then if no one has questions, feel more than happy to go. So let's say we have a question like, find the voltage. So we're finding voltage given a, you know what, let's flex this. This is going to be way easier. So what is the voltage in a circuit with 10 amp with a speed, because remember current is speed, of 10 amps and a resistance of 6 ohms. Okay, so right away, we know a few things here. We're looking for voltage and we're given amps, which we know is current, and we're given resistance, which we know is, or we were given ohms, which we know is resistance. So you can use this equation here, I equals V over R, but this time we're not solving for I, we're solving for V. So we have to redo this equation, which is just this. Voltage equals I times R. This is an I. And I did that equation by either A, you can memorize them, or if you ever forget, you can just do the math here by getting V by itself, looking at this equation, you can just multiply by R on this side, multiply by this side, and then the R goes away. Okay, so it's as simple as putting in I, we know is 10. And your resistance, you know, is 6. You should probably put the units here just in case we ever, I don't think you ever have to, but if you ever have to do with unit conversions, it's good to put the number in there. So we have 60 volts. That's a horrible 0, but you get the point. So that's how the problems work. The other thing I think is important to note too, you could have decimals, so don't worry about that, especially for like when you're calculating I and you have to do V divided by R. If you have like 10 divided by 2, like a voltage of 10 and a resistance of 2 ohms, or that's going to give you an even number, 10 divided by 3. If you have an ohm of a resistance of 3 ohms, you might get 0.33. That's totally fine. So sometimes your answers might be decimals, just round it, which that's why part of this math portion talks about rounding. Does this make sense to everyone? Are there any questions about the math portion here?
Yeah, I have a question.
Yeah.
Could you maybe explain how when you're in the equation and you said divided by R and then it goes to the other side?
Oh,
and
yeah.
how
Okay.
an easy way to remember that? Could you go over that?
Yep, of course. Let me erase this. So, and this is just an algebra rule, and I don't know enough about like what you're talking about this week in your math course. But it definitely is an important algebra rule. So right here where I have written I equals V over R, that V over R, I hope, do you know that it's the same as writing it like this? Does that make sense? like this is the same as this, just the R.
Yes.
Okay, just making sure. So let's pause me whenever you get confused and then we'll go from there. So one of the rules about fractions is if you have two sides of an equation. So right here, this is an equation, I equals V over R. We have letters on both sides. If you have anything in a denominator and you want to move it to the other side, you can do so by multiplying this whole equation by whatever's on the denominator. And I'll do an example of this with numbers, and I think it'll make sense. So I'm right now, all I'm doing is multiplying V over R. So the right side of this equation, V over R times R. But whatever you do to one side of an equation, you have to do to the other side of the equation. And I will explain this in numbers and it will make more sense. Remember, this is an I. But anytime you have the same thing on the top and bottom, you can cancel it out. They cancel each other out. A perfect example of this is when you have something like this. If you have 1/2 and you multiply it by 2, your 2's cancel and you're left with 1. And it's true, like if you do the math right now in your calculator, 1/2, which is 0.5 times 2 is 1. And that is exactly what I'm doing here. So if you have a fraction and you have a numerator, which in this case is 1, and a denominator, which in this case is 2, and you multiply it by something, you can X off anything that's the same. So the 2's, or in this case, the R's are the same. And I think, does that make sense to you? Like the number portion of it, why canceling these R's works?
Yeah, that made a lot more sense.
Okay, perfect. And I think too, making sure that this is also kind of confusing why multiplied by R on the other side. So I think showing that in numbers is important too. So let's say we have an equation that looks like this. Tan equals 20 over 2. This is a true statement, just like all I'm doing here is putting an algebraic equation into numbers, which you can do. People, they just don't normally explain it like this, but tan equals 20 over 2. And we know that tan equals 20 over 2, right? Because 20 over 2 is just 20 divided by 2, which is 10, which is the same thing all these equations are saying. It just, whoever came up with Ohm's law just figured out that when you had a voltage and a resistance and you divided them by each other, it was going to equal your current. It's the same concept here, that 10 we know is going to equal 20 over 2. But let's say we're trying to solve this or prove that it's right? We multiplied this side by 2. We could cross off our 2's, but now we have 10 equals 20, which you know is not true. But if we follow the same rule here, where I multiplied both sides by R, we know that in this case, R is 2. So I'd multiply R, which is 2 on this side. And then 2 times 20 does, or 2 times 10 does equal 20. So that's just putting this concept into numbers. Did you follow that? I'm hoping.
Yes.
Okay, good. I hope that helped. Any other
Yes,
questions?
thank you.
Yeah, of course. That, I think that is confusing, and I never really understood it because they always like show that in math and then never say like why it works. And I think that definitely can get confusing. So whenever you have like algebra and you can put it into words or you can explain it using numbers, it makes way more sense. So if there's no more questions on this, I'm going to move on to the last little bit I have. But as long as you understand how to find current, resistance, and voltage, you will be totally set for this week. And you'll always get 2 unknowns or 2 knowns. So like you're never going to be asked to solve for current if you're only given voltage. You can't do that. So you're always going to be given 2 things, like how I'm given 15 and 3 here, how I'm given 10 and 6. So you're always going to be able to, at least for this week, be able to solve the equation just because you're going to be given 2 numbers and you're only going to have 1 unknown. Okay, so let's stop my annotation and move on. Oh no, they're still there. Let's see if I can remove this text box here. Oh no, okay, well, sorry. We're gonna have a jumbled mess here. this is the last little bit here. So direct current and alternating currents, we're going to talk about these a lot more. And basically, I just want to give a brief overview for now. The direct currents, which is denoted DC, is when the flow of your electric charge is in one direction. So that example I showed at the beginning, that simple circuit was electricity flowing in one direction, right? We had the arrows going in one direction. And it is something like a battery is always going to be that DC circuit. Something like alternating, which is what we use for modern day electricity, which we'll focus a lot more on that in a little bit, is when you have alternating current. So it's when the flow of your electric charges in a circuit is not just going in a straight path, it's going back and forth, which is how right here denoted, you can see this arrow that's going both directions, whereas in the DC supply circuit, it's only going one way. So that's really the only difference. And we'll talk more about like how that impacts like the loads, or the lights in your circuit. We'll talk more about how that impacts certain different things, impacts calculations, etc. But just that's the main idea there. Also, you'll notice here this little like Z thing that is written here. The Z, that always means that you're dealing with an alternating supply. That's like the symbol for alternating current. Anytime you have a battery, you're typically dealing with direct current. So those are just your power supplies like we talked about at the beginning. But in this one is just telling you, it's not giving you what the power supply is. So you don't always know. But that is a point to bring up for next week. You can see right here that your power supply, which is what's pushing your electrons through the circuit, is written right here, 10V, which we know V is volts, which makes sense with what we talked about at the beginning, that volts or voltage is the push that is moving your electrons through the circuit. All right, I think that is all I have. Oh, no, last thing. This is on the quiz, so that's why I added this today. And I'm totally sorry about this annoying where it's written, but I don't want to waste your time and try to erase it for 20 minutes. So basically the only thing to remember about fuse and circuit breakers for this week is that they're safety features that are added to a circuit or to your electrical component. And the safety feature is they ultimately prevent fires by stopping surges of current. So large amounts of speed going through your electrical components there. So they just prevent fires. That's really the main thing. And how they prevent fires is a little bit different. Fuses are a lot smaller. Circuit breakers, which we see in our houses, are a lot bigger of a component. So that's really the main difference there. I think this diagram does a great job. I took this off somewhere, I can't remember where. But basically your fuse is a device working on the electrical and thermal properties of the conducting material, whereas a circuit breaker is working on the electromechanical principles. So basically how they're working is they're transferring energy, because ultimately when we're dealing with electricity and we have safety features, all the safety features end up converting that electrical energy, if it's too high, into something else, into alternate forms of energy to make it so we don't have a lot of electrical power energy going through a circuit, because obviously too much electricity is how you get things like fires. So something like a fuse is just using thermal properties, and thermal, hence thermal energy, electrical, hence electrical energy, but that's what we're converting. And then a circuit breaker just uses electromechanical, which mechanical energy is a form of energy, which you'll talk about in later courses as well. So that's really the main idea, is they both work in different ways, but ultimately they have the same overall goal of just preventing fires by stopping surges of currents. But that's really the only thing you need to know for now, and probably I think for the rest of the course, just knowing that little bit. But that's all I have. So I'm going to stop there. And then are there any questions about anything I went over, anything about how this course is going to run? Like I mentioned, Kayla, I'll send you an email about, you're the one that writes the Amatrol module.
Yes, I am.
Perfect. Okay, I will send you an email by the end of tonight.
And you'll check into the first attempt, because I didn't, is that what you're talking about?
Yeah, the Amatrol, you only get one attempt. So just know that for like later weeks, but obviously this week we'll figure something out. Because you
Okay.
can do that. But I'll send an email to everyone letting them know that you get 2 attempts for your electrical quizzes on JetNet, 1 attempt on the Amateur.
So, Ms. Summer, if we have any question during the weeks, something that we don't understand, we can always contact you, right?
I'm sorry, can you repeat that?
If we have any questions during the week, everything, we can always contact you, right?
Oh, of
If we need
course.
help.
Yep. You have so email me whenever you have a question.
All right. Thank you, Mr. Summer.
Yeah, of course.
So,
Anything-
so would you like me to wait to do the amateur until you got that figured out of the first attempt?
What do you mean wait? Like wait before you do like week-
Because you said that we only get 1 attempt, but I already did that and exited out on accident.
does it
so
give
wait.
you a second attempt on amateur?
It does say second
Oh,
attempt.
then take 2 attempts. I didn't know that. Then you guys are fine. If it lets you take 2 attempts, take 2 attempts.
Okay.
and then if-
in the future, I'll just remember that.
Yeah. I didn't know that. I thought amateur only it used to only let you
I'm pretty sure that's what it said.
Okay, yeah. So if it lets you do that and email me if it or do it today and then are you gonna do it today?
I don't know if I'll probably do it tomorrow, but it does. I just looked at it and it does say number of attempts allowed 2.
Okay, perfect. Well, since you accidentally took 1, take your second attempt and if you want to redo it, I will see about like if I can
Okay,
do that.
that's perfect.
protect
Thank
that.
you.
But for everyone else on here, if it lets you take 2 attempts, take 2 attempts, and it should take the highest of the 2 grades. So you might have 2 attempts for both your electrical quizzes and your circuits. I didn't know that. So if it lets you take 2 attempts, I totally take it. But yeah, I'll just email me in the night when you take it, and I'll check and make sure that I have a grade for you on it.
Okay, thank
Go
you.
from there. Yeah, of course. Anything else? Well, if not, you're totally free to go. And like I said, this is not mandatory at all. I'm just here to help in any way that I can. So if you're busy one week, if you need it, you don't have to come. If you need extra help, I will always be here at 6. So thanks for coming.
Thanks, Miss.
Yeah, of course.